The top two panels are comparing to Hurricane Katrina, which was not as wide in extent of the storm. And it created a storm tide of over 14 feet above the main tide gauge at the battery, the tide level. And it had a very unusual storm track. Remember how it was going up north, and then it veered inward, landward, in a very unusual way. One thing that's very important for science, which is cut off, I see it on mine, in red at the bottom it says that the storm was forecast well in advance. This is very important for science, very important for climate change. Because if we can do a good job forecasting our near-term big storms, this is also, it builds confidence in the models which are used in the longer term as well to project climate change. Now, I have to talk about the links of Hurricane Sandy to climate change science. This is extremely important. This was the second big media question that was asked. Was Hurricane Sandy climate change? The answer is no. Climate, by definition, is long-term weather. No one storm will ever prove climate change. But we can say that the sea level rise that has already occurred, there has been 1 foot of sea level rise in New York City already, for sure exacerbated the coastal flooding that Hurricane Sandy caused. So there is a direct link, because some of that sea level rise, not all, some of it is glacial, but remember I was talking about the thermal expansion and the melting of the land-based ice. Now, it's also very important to know that there has been an increase of the intensity of severe hurricanes. This is in the Northeast. This is in the actually North Atlantic. You can see that's what the second panel is showing. This is an area of research, but it is it's definitely intense storms are on the rise over our larger area. And there may also be a connection to the melting of the sea ice in the polar regions, which may have affected the jet stream and may have affected that left hook. But what we're also very clear about as we talk about the climate science to decision makers and to the general public, we work very hard to be clear about what we can say for certain and what are areas of research, so that we're not saying everything is climate change. We're also teaching about the process of learning about the climate system, which is part of this flexible adaptation pathways and monitoring and reassessing. So in the immediate, because it was well forecast, the storm, there were preparations. So New York City issued the mandatory evacuation of Zone A, and many thousands of people evacuated. Out-of-state utility crews were brought in. The MTA closed down its operations. It moved its rolling stock. And I think in contrast to New Jersey Transit, which did not move its rolling stock, sorry, apologies for bringing that up for the folks from New Jersey. And they placed sandbags at the entrances. And a lot of these things were done because they hadn't been done very many times before. And I do believe that the New York City Panel on Climate Change and working with the climate scientists, becoming aware of the risks of climate change, helped, because we've worked with the MTA now for years, and it helped to make these kinds of decisions, and OEM in New York, that reduced loss of life. Because when you contrast the loss of life, which was only, this is in New York City, 43 people, of course, every loss of life must be avoided. But you can see that definitely loss of life and damage was reduced. However, utilities not prepared, 4 million without power for weeks in the tri-state area. And we did have major flooding, but by closing, we did reduce damage. Now, I said that the storm was well forecast. What about the impacts? What happened with the storm? It turns out these were well forecast too, because of the series of foundation reports, which started back actually 15 years ago. And in the maps, in these reports, you can see the vulnerable areas, which indeed were the hardest hit in Sandy. Overall, these reports reveal two major vulnerabilities. One is the interdependent critical infrastructure systems, which is what this group is really focused on. It also revealed the vulnerable communities that we have in our densely populated coastal areas. However, there were always some surprises, and these were the ones that were unforeseen. The hospital evacuations, we just didn't think that we were going to have to evacuate those hospitals. The gas shortages, which were caused by severe breakdowns in the supply chain of the gas. And then the fires in some of the really tiny coastal communities, which were a combination of electrical fires with interaction of the electricity, the seawater, and then the narrowly flooded streets hampered emergency response. There are always going to be surprises, so we have to prepare. How do you prepare for a surprise? We have to be ready for them. We have to do as much as we possibly can. These were some of the surprises of Sandy. So immediately following the storm, Mayor Bloomberg reconvened the New York City Panel on Climate Change and asked us to prepare an updated climate risk information for 2013. Because in the meantime, the International Governmental Panel on Climate Change had been preparing their fifth assessment report. But I just want to, I don't know if you can see it, and so we did a new report. We worked 24/7. Science, proceeds actually like on a slower time frame, but we had to work. We really worked from January until June. We worked to provide the new updated risk information that went along with the plan, which I'm going to describe. This stronger, more resilient New York, which was the actual plan for rebuilding and creating a resilient New York. And so I just want to read this. You may not be able to read it, but I think it applies to Boston too. Resilient. It's the definition. Able to bounce back after change or adversity, capable of preparing for, responding to, and recovering from difficult conditions. Synonym, tough. See also New York City. But I would also say Boston as well, because we're sisters cities here on the Northeast. I want to here mention, besides the New York City Panel on Climate Change, which was just focused on the New York metropolitan region, NOAA has a program that has regional programs throughout the country called RISA, which stands for Regional Integrated Science and Assessment. And we have one in the urban Northeast. It's called CC-RUN, Consortium for Climate Risk. And this stretches from Boston, and the work of the scientists here stretch from Boston to Philadelphia. And the CC-RUN actually led the technical team that developed the projections for the NPCC2 report. And here's what here are the updated findings. A broad-based acceleration of climate change in coming decades, significant climate risks. Let's not forget heat waves and the extreme precipitation events, even as we're focused on coastal flooding. This is valid not just for New York City, but for the whole New York region. I won't read the fine print, but in this report, and it's on the web already, you can look up to see how many degrees Fahrenheit, how many inches of sea level rise, et cetera, et cetera. This is because if we're really going to be serious about infrastructure, that building, we have to know what these projections are. And what New York City did with these is make a very detailed plan for coastal protection. And these are just some examples of how detailed their plans were able to be. Increasing coastal edge elevations, minimizing upland wave zones, protecting against storm surges. That's where the local storm surge barriers come in. Improving coastal design and improving governance, a very key part. You can't only just think about infrastructure. You have to think about how the governance of the infrastructure and the telescoping scales are handled. And then I put in a whole slide about insurance. Again, I'm not going I won't go into the details. But this illustrates that there are, remember, we have engineering solutions, we have ecosystem-based solutions with the wetlands, for example, the dunes, and we also have policy adaptations as well. You can see that what New York did was create a portfolio of adaptations, and clearly insurance that targets affordable solutions for low-income policy holders, defining resiliency standards for buildings. There are lots of lawyers here. These are the kinds of things that we'll be turning to the lawyers to really, and the engineers, to be creating these new kinds of regulations. Expanding pricing options. There's so much that can be done with insurance, and this will clearly be a critical part of the federal response as well. And already there has been with the Bigger Waters Act. This work has already begun. Oh, and what the graph is showing is that Sandy may be, it's looking as if it's going to be the third most costliest storm for the United States. So this is the final slide. Hurricane Sandy as tipping point. I really do believe that Hurricane Sandy is the tipping point for this country in terms of responding to increasing climate risks due to climate change. First of all, New York really did lead the way. New York City is a leader. It's a cultural leader. All the media are there. For a number of reasons, it was able to really take a leadership role. A key part is in the response is in New York City, is that there was, and continues to be municipal, state, and federal alignment. Mayor Bloomberg, Governor Cuomo, and President Obama all publicly spoke about the need to include increasing climate risks in the spending of the funds of the appropriations for resiliency development. This alignment of the telescoping jurisdictions is, I believe, a very key point. The third is about the climate science. The climate science, I call it, was in place and in time. Because you can't have a storm like Sandy and have Mayor Bloomberg call us up for the first time the day after. You will not get the understanding of what the risks actually are, so that the science and the development of the climate risk information, and that's why the National Climate Assessment process is so important, that we as a nation are finally getting our act together nationally, so that we can have climate science in place and time everywhere, not just in the fortunate places like New York City, because we happen to have Columbia and NASA GIS and all the great universities and risk management firms we have there. And so those, I believe, are why it's a tipping point. I believe very strongly as we go forward, I want to emphasize this again, that we need federal coordination that recognizes local and state initiatives, because one of the things that we've done as part of this is work with NOAA and Army Corps of Engineers, and it's been great because they recognized that there was the detailed hyper-local projections that were better than any national projections could possibly be. So just as we have to have a flexible approach for our pathways of adaptation, we have to build in flexibility into our policies, into our jurisdictional relationships as well. So I wanted to emphasize